welcome to Quadratics, where we make high school life simple. I'm Mariam, and in this video we are going to solve questions from non-linear functions from the advanced math section. This is of medium difficulty. If you want to learn the basics of non-linear functions, please check our previous videos. Also check out our YouTube channel Quadratics for more SAT math content. So let's look at our first question. We have s of n to be equal to 38,000 times a to the power n. The function s above models the annual salary in dollars of an employee n years after starting a job, where a is a constant. If the employee's salary increases by 4% each year, what is the value of a? To understand the question better, let's learn what an exponential function is. To understand the real-world problems such as computation of interest, the growth of a population or spread of a disease, or even the decay of a radioactive element, we make use of the exponential function to formulate an equation that describes the significant growth or decay of a scenario in a short interval. The general form of the exponential function is given by f of x, which is equal to a multiplied by b to the power x, where a is not equal to 0 and b is not equal to 0 and b is greater than 0. So my exponential functions could be of two types, either increasing or decreasing. So the examples of an increasing exponential functions could include the computation of compound interest or growth of a population or even spread of a disease. These examples have a significant increase in the values of your function. Graphically, the increasing exponential function would look something like this. So this is my x-axis and this is my y-axis. An increasing exponential function would look something like this. So you can see within a short interval there is a significant increase. The most common example for a decreasing exponential function is the decaying of a radioactive element for a given period of time. Graphically, the decreasing exponential function would look something like this. So this is my x-axis, this is my y-axis. So the decreasing exponential function would look something like this. So where there is a significant decrease. Coming back to our question is an example for increasing exponential function, and it is similar to any compound interest problem. So let's write a compound interest formula. We have the final amount a to be equal to principal times 1 plus the rate of change r divided by number of times the rate of change is applied, that is n, and to the power n t, where t is my number of years. So I'm gonna rewrite this compound interest formula with respect to the equation above. So let's write s of n, which is equal to the principal amount, that is 38,000 times 1 plus, now I'll have to convert the increase which is in percentage into decimal form. So I have 4 divided by 100, which is equal to 0.04. Now substituting that value over here, 0.04. Now the increase is happening annually, so I'm dividing it by 1. And here 1 times the number of years is n, so I'm just going to write n. So which is equal to 38,000 times 1.04 to the power n. So I'm just going to equate my s of n of this equation. I'm going to equate it with the s of n of the given equation. So we have 38,000 times a to the power n, which is equal to 38,000 times 1.04 to the whole power n. So I'm not going to take a long route of dividing both sides by 38,000 and taking the nth root. I'm just going to simply equate my a value to be equal to 1.04, since both the equations are similar. So let's see our options. Option C is my correct answer. So let's look at our next question. So we have been given a graph. Which of the following could be the equation of the graph shown in the xy plane? Before we could solve the question here, let's understand the roots of the equation, or how do we deduce the roots from the given graph. Firstly, let's consider a quadratic equation f of x, which is equal to ax square plus bx plus c. So we can find the roots of the equation using the quadratic formula x is equal to negative b plus or minus root of b square minus 4ac divided by 2a. We can either use this formula or use factorization or even use trial and error to find the roots of the equation. But this is only possible only when there is an equation present. How do we find the roots and formulate an equation with only a graph present? Therefore, we need to consider the x-intercept of the given graph. So x-intercept is nothing but the curve or the line which intersects the x-axis at y equal to 0 is my x-intercept, and it is represented as a comma 0. So x-intercept is also known as the root or roots of the equation. So let's consider the quadratic equation here. So in the graphical form, it can be represented as follows. So let's take our y-axis and let's take this as our x-axis. So the quadratic equation can be represented in the form of a parabola, which is like this. Now let's look at the x-intercept of this graph now. So we know that x-intercept is nothing but the curve which intersects the x-axis at y is equal to 0. So which is a point here and another point over here. So we'll just name this as R1 and R2. So we know that the solution of the equation can be written in the form of the roots, that is x plus R1 and multiplied by x plus R2, which is equal to 0, is another form of writing the quadratic equation, that is ax square plus bx plus c. So when I'm substituting the values for a, b and c and I'm finding the values for r1 and r2, I will get the same equations. So this is one way of writing the equations after finding the roots. So coming back to our question, so let's find the roots of the given equation. So we'll have to consider our x-intercept, where the curve or the line which cuts the x-axis at y equal to 0. So I'm going to shade the curve in such a way it's easier for us to identify the roots. I'm going to start off by shading the curve from this side. So this part passes through the coordinate 4 and reaches here. Again, the curve passes through the origin and the curve simply brushes the coordinate negative 5 and goes like this. So I can easily identify my roots here. So one such root is my x is equal to 4 and x is equal to 0. And here, since it does not pass through the coordinate, this is called a repeated root. So I'll have minus 5 twice. Hence my roots are going to look like x is equal to 0 and x is equal to 4, and I'm going to have x is equal to negative 5 and negative 5. So I'm just going to rewrite this values as x equal to 0 and x minus 4 is equal to 0 and x minus 5 the whole square is equal to 0. So this is my first condition, where the equations over here must satisfy these values. And secondly, I'll have to see what is the degree of the polynomial here. Now, if I have 4 roots, then the degree of the polynomial is going to be 4, and there should be a term with x to the power 4 value. So let's consider our first equation. So first equation is y equal to negative 1 by 10 x times x minus 4 x plus 5. So if I multiply the x in both of these terms, I'm going to have a coefficient that is only x cube. So which is wrong. My condition over here doesn't satisfy. So option B, y equal to negative 1 by 10 x times x minus 4 x plus 5 the whole square. So my values are also present and the degree of the polynomial also is satisfied. So option B is my correct answer. Option C and D are obviously wrong. A rectangle has a length of x units and a width of x minus 15 units. If the rectangle has an area of 76 square units, what is the value of x? So let's draw a rectangle to understand better. So in the length, I'm going to take my x value, and in the width, I'm going to take my x minus 15 value. So the rectangle has an area of 76 square units. I'm just going to write that here. So we know that the area of the rectangle is given by length into width, which gives my area of the rectangle. So I'm just going to plug in my values of this rectangle in the formula here, and I'm going to write it as x multiplied by x minus 15, which is equal to 76. So multiplying x here, I'm going to get x square minus 15x, which is equal to 76. Subtracting 76 on both sides, I'm going to get x square minus 15x minus 76, which is equal to 0. Here I can either use my quadratic equation formula to find the roots, or I can simply factorize it by using the trinomial formula. So here I'm going to use the trinomial one. So I'm going to split the 76 into two numbers such that when multiplied, I'm going to get a negative 76, and when I add them together, it's going to be negative 15. So to get those numbers, I'll have to use, I think, negative 19 and plus 4. So let's rewrite our equation. X square minus 19x plus 4x minus 76, which is equal to 0. So I'm going to just take the common terms outside. Here it is x. So I'm going to take x multiplied by x minus 19 plus, here the common term is 4. So I'm going to take 4 multiplied by x minus 19, which is equal to 0. So I'm just going to add the like terms. So I have x plus 4 multiplied by x minus 19, which is equal to 0. So my x values are going to be negative 4 or positive 19. So I can't have a negative value, therefore my negative 4 is excluded. So let's see, our option is only x is equal to 19. So let's see our options. Option B is my correct answer. Let's look at our next question. G of x is equal to x square plus 55. What is the minimum value of the given function? So let's consider the standard form of a quadratic equation. We have f of x, which is equal to ax square plus bx plus c. So for a function to have a maximum or a minimum value, let's consider the coefficient of x square. That is, f of x has a maximum value if a is less than 0 and a minimum value if a is greater than 0. So let's take our given equation. So we have g of x, which is equal to x square plus 55. Now comparing with the standard form, we have a to be equal to 1, b to be equal to 0, and c to be equal to 55. Here my a value is greater than 0, therefore it has a minimum value. So I have x to be equal to negative b by 2a, which will give me 0 divided by 2 times 1, which is equal to 0. Now substituting my x value in the given equation, I have g of x, which is equal to 0 plus 55, which is equal to 55. So 55 is the minimum value of the given function. I can find it this way, or I can directly substitute and get the value of the minimum value. Y equal to g of x, which is given by c minus b square by 4a, which is equal to, in c we have 55, we have 55 minus b square is 0, so anything divided by 0 is 0, I have 55. So either way I get my answer to be 55. So option B is my correct answer. So let's look at our final question. The graph gives the estimated number of catalogs Y in thousands a company sent to its customers at the end of each year, where X represents the number of years since the end of 1992, where 0 less than or equal to X less than or equal to 10. Which statement is the best interpretation of the y-intercept in this context? So all we have to do is find the y-intercept and understand what it means for this graph here. So in the y-axis, it is the number of catalogs sent, and it is in thousands. And x-axis represents the number of years. So we'll write years here. So the initial year, that is when x is equal to 0, it represents the year 1992. So at the origin, we have the year 92. So we know that the y-intercept is nothing but when the x value is equal to 0 and the curve intersects the y-axis at some point, then that point is called the y-intercept, that is 0, b. So let's look at the curve here. The curve intersects the y-axis at x is equal to 0 at this point here, that is 9. So here the y-axis has the units in thousands. So the 9 over here represents 9,000 and not 9. So let's write that in our y-intercept form. We have 0, 9,000. So what it means is when x is equal to 0, it represents our initial year, that is 1992, and it means that the number of copies that or the estimated number of catalogs sent to the customers is 9,000 for that year. So let's look at our options. We have the first option, that estimated total number of the catalogs of the company sent to its customers during the first 10 years was 9,000, which is wrong. And the option B, the estimated total number of the catalogs the company sent to its customers from the end of 1992 to the end of 2002 was 90, which is again wrong. And the estimated number of the catalogs the company sent to its customers at the end of 1992 is 9, which is wrong because our units is in thousands. So the final answer, the estimated number of the catalogs the company sent to its customers at the end of 1992 was 9,000, which is my correct answer. So thank you for watching our video. Please like, share and subscribe.